Okay, here we go. This is actually like the fifth time I try to make this video. It keeps the sound recorder keeps going out. So after I've uh, done the video, I check it. The sound's gone, so hopefully it works this time. So here we go. So when you do partial products, that's what we're working with on this video. The reason why you do partial products is that you get a better understanding of the values of the numbers that you're working with. When you do just a regular algorithm, uh, it's just a pattern. It's just you don't. I mean, you're doing. It's okay to do the regular algorithm during the test, but when you're practicing, your understanding of the value of each number of the place value gets better. For example, here you are multiplying 4 times 5, which is correct. But here, on this one, you're not multiplying 4 times 5. You're multiplying 4 times 5 tenths. And when you do it the just regular algorithm, that you just go, oh, 4 times 5, 4 times 5, 4 times 7, then you get whatever the product was. But when you do partial products, you get a deeper understanding of the number, right? Of the value of the number. It's called your number sense increases. So here we go. So 4 times 5 ones, you get 20 ones. If you hear voices, I'm watching TV at the same time I'm doing this. So 20 ones, right? Or 20. 4 times 5 tens. I like to put a little placeholders here to remind me that I'm working with the tens, especially since I'm not going to have this whole setup every time I do partial products. 4 times 5 tens is 20 tens, or 200. Then, since we're working with the hundreds, I know my lines could be straighter, but that's just how it is. I'm not very good in straight lines. 4 times 7 hundredths, 28 hundredths. Then you add. Oh, sorry. The TV's a little loud. Let me put the volume down. Then you just add 0 ones, 2 tens, 8 hundredths plus 2 hundredths is 10 hundredths, or 1,000. 2,000 plus 1,000 is 3,000. Now here you go. This is how you should be able to do it on the paper. That just partial products. 9 times 7 ones would be 63 ones. Now I'm working with the tens. 9 times 1 10 would be 90 tens, or 90, right? Now I'm working with the hundreds. 9 times 500 would be 4,500. Okay, so now then we add 3. 9 tens plus 6 tens is 15 tens. 100 plus 500 is 600, and 4,000. So the product's 4,653. Let me show you. So if you do it just the algorithm way, or the regular way, or the faster, shorter way, I guess, you don't really have to say 1/10 or 500. So you just go 9 times 7, 63. Don't forget to regroup. 9 times 1, 9 plus 6, 15. Don't forget. 9 times 5, 45 plus 1, 46. You get the same answer, you get the same product, but what happens a lot of times when students go fast, they forget about this. They forget to do this right. So they make mistakes. They multiply 9 times 7, they multiply 9 times 1, they multiply 9 times 5, but for some reason they forget to add whatever they regrouped on the top. But if you do it this way, there's no need to remember what you regrouped on the top, because there's nothing there. There's nothing there to remember, right? You already multiplied times ones, times tens, and times hundreds, and you already did down here. What happened when you multiply times the ones, times the tens, times the hundreds? So that's why partial products, it's gives you a better understanding of working with numbers, and it's a lot harder to make this mistake of not adding these to your final product. Okay, I hope that helps.